Alright, so this is Honors Geo 7.3, similar right triangles and their uses. Okay. So, here's what Theorem 7.5 says. This is going to be a tricky section, y'all. Theorem 7.5 says that if we draw an altitude uh, to the hypotenuse of a right triangle, then the two right triangles are formed or similar. So here's our triangle. ABC. And here is the 90-degree angle. We draw an altitude. Remember, altitude is a line that goes straight down and forms two other 90-degree angles. But it's not a bisector. Then we cut this up into, actually let's make this a little better so it's easier to see. So we have a triangle. Yeah. There we go. Let's do that. We have a triangle. Oh, I see how they're doing it. We have a triangle. Here's the altitude. Comes straight down. And it forms the 90-degree angle. It's altitude. A, B, C. From that altitude, and they connect at point D. From that altitude, two other triangles can be formed. Here's the other triangle that's formed. And here's the other triangle that's formed. So we have, I call it a big triangle, a medium triangle, and a small triangle. These triangles are all similar. Okay, these triangles are all similar. When you form that altitude. So if we were looking at this, they already did it for us. So ABC, which is the biggest of the triangles, is similar to the smallest triangle, which is CBD. ABD is also similar to the bigger triangle. I'm not drawing the triangle symbols. ACD, you can draw the triangle symbols. And then triangle, the CBD, that's similar to triangle ACD. So we have three sets of, or three pairs of two similar triangles when we form this mean from altitude. Okay. So down here, we have a situation where they wanted to find the value of x, and we could do that using similar figures and ratios. Because remember, or proportions, because similar figures are proportional. So here we have a 3, 4, 5 triangle. So I'm going to just, these are not to scale. I'm just drawing them so I can exaggerate the small side, the small leg, big leg, long leg. So here I have EGH. Where this is 3, this is 4, this is 5. So this is the small leg, medium leg, hypotenuse. I base everything off of the hypotenuse. So if I look at the medium triangle, Again, I'm not making these triangles to scale. They meet at H, right, because it's perpendicular to the H. The hypotenuse is here at 4. And then it meets over here at F, right? The hypotenuse over here ends at F. This is the shortest side, so this is from G to H. And then the shortest side in this case for the medium triangle is X. So it's GHF. Then we have the smaller triangle. Again, everything is based off the hypotenuse, so it's at I'm sorry. The hypotenuse is across from the 90-degree angle, so that's 3. This guy was the shortest guy of the medium, so it's going to be the longest guy of the small. So this is here's E up here. So this is going to be G, and this is going to be from H to G, which is X. These can be tricky to draw sometimes. So when we do our ratio, I'll do I'll use these two, 5 over 4. So big to small, and then big to small, 3 over X. So I got 5x equals 12, x equals 12 over 5. So that's why I find out the length of x. So we have another one here. And I'm gonna draw it this way. It's easier for me to see it this way, but if you want to, you can draw it however you want to. Looking at the big triangle, the smallest side is 5, L, M, J. Hypotenuse is 13. The smallest side is 5, biggest side is 12. So then when I do the medium size, again, everything starts from the hypotenuse, so this is going to be K. The hypotenuse of that is 12. This is going to be M up here. That's X. And then JK, we don't have enough to find out. So that's the medium guy. And then the small guy, this X was the shortest guy, the shortest leg, which is now the longest leg of the small guy. So it's X over here. Here's my K. This one is going to be L, and that's going to be M. L to M is the hypotenuse, which is 5. Okay, so I can pick any one of these to find my X. So I'll use this and this again. So 13 over 12 is equal to 5 over X. So that's 13x equals 60. So I can say that x is equal to 60 over 13. I'll keep it as a fraction. You guys can turn it into a decimal if you want. Okay. Alright, this is where it gets fun. Let's say we have this triangle. We break it up into 3 parts. So we have I don't even look like 90 degrees. We have our ABC. We have our altitude that drops down. This is 90 degrees. We have our altitude, and it forms two other 90 degrees at point D. All right, this is CB is the short leg of the big triangle. AC is the long leg of the big triangle. AB is the hypotenuse. If we look at the medium triangle, AC is the hypotenuse, CD is the short leg of the medium triangle, and AD is the long leg of the medium triangle. If we look at the short triangle, CB is the hypotenuse, DB is the short leg of the small triangle, and CD is the long leg of the small triangle. Alright, they call them longer, shorter. We can put these guys up into three triangles here. So they call this triangle number 1. Which is the smallest triangle. And it's BD and C. So if we look at the triangle, the hypotenuse is CB. So this is in blue. And this is the longer leg of the shorter triangle. So CD is in the red. And they call this triangle number 1. Triangle number 2. Slightly bigger. This is the median triangle, ACD. And of the median triangle, the short leg is CD. And the hypotenuse is AC. And then we have the birth, oh, this is number 2. Then we have Bertha, number 3, ABC, and B, oops, why did I do that? And then these are the legs, so the short leg is BC, and the long leg is AC. Okay, so the ones in blue and red are things that they share. If we look from the small triangle to the medium triangle, they both share CD. The long leg of the short triangle is the same thing as the short leg of the long triangle. If you look at the big triangle, they share characteristics with both of these guys. The hypotenuse of the small is the same thing as the short leg of the big triangle. The hypotenuse of the big is the same thing as the long leg of the big. So short, short, big, big. Okay. Here's what they're talking about in terms of the concept of a mean, a geometric mean. So a geometric mean is a situation where you have a ratio in which one of the diagonals are going to be the same number. One of the diagonals is going to be the same number. So we would say that x is the geometric mean, right? It's a ratio where the one of the diagonals is the same number. So when you solve for x, it's going to be x squared equals ab, and then x equals the square root of ab. All right, so with a lot of these, if you're looking for that geometric mean, it's going to be a square root of some number. This is a geometric mean. And we're going to use that concept of the geometric mean to help us find various shapes using similar figures. because if you notice, uh, these red and blue lines are situations or scenarios in which they both share the same thing. CB or CD are shared by the small and medium, and then uh, CB and AC are both shared by the big and the small and the big and the medium. And since they both share it, we can use the geometric mean in order to solve. So, the first one they give us is BD. So this is the short leg of the shorter triangle. So you have BD over, and this is the side that they share, right? They share this side. So BD is the short leg, or the, what do they call it? The length of the shorter leg of the small triangle. So the short leg of the small triangle over the short leg of the medium triangle. Well, that short leg of the medium triangle is also the long leg of the short triangle over the long leg of the short triangle. So small to big, right? So CD over AD. Right. So this BD would be the short leg of the small triangle over the short leg of the medium triangle. So short leg of 1 over the short leg of 2 is equal to the same thing as the long leg of the 1 over the long leg of the 2. That's the first one. The second one has to do with hypotenuses. So the hypotenuse of the biggest one, 3, is the same, so AB, as the hypotenuse of the smallest one, 1. That CB is also the shortest leg of the biggest triangle, 3, which is over the shortest leg of BD, of 1. So hypotenuse of 3 over the hypotenuse of 1 is, this hypotenuse is also the short leg of 3 over the short leg of 1. Then we have, we're going to do the hypotenuse again for the big one. The hypotenuse of 3 over the short leg of the medium. I'm sorry, of the hypotenuse of the medium, or hypotenuse of 2, is the same as the short leg of the medium. I'm sorry, AC. It's the same thing as the long leg of the biggest triangle over the long leg of the medium triangle. Right, so short leg, hypotenuse of 3 over the hypotenuse of 2 is equal to, which it shares, is the long leg of 3 over the long leg of 2. It's going to be really, really tricky to see. So when I think about these things, and I don't think you guys are going to like this, but this is sort of how I do this in my head. So they want you to draw similar figures. I'm not going to draw similar figures. So we have a Y. This is R. S P Q 9. Alright, so they want me to find Y. I can draw the similar figures. I can draw the triangles if I wanted to. Or I can use those means. And the way that this works is I have hypotenuses over here, right? Here's a hypotenuse over here. And then I have this 3 over here. Since I know I have all these hypotenuses, I have nothing in here, right? The altitude itself. If I look at the hypotenuse of the big, right, that's 9. So I have 9 over, and you see right here, this is opposite of this 90 degree, so I could put over y. So hypotenuse over hypotenuse. Hypotenuse of the largest triangle over the hypotenuse, this is of the smallest triangle. The hypotenuse of the smallest triangle here touches this part right here. The hypotenuse of the smallest triangle touches the hypotenuse of the biggest triangle over here at RS. This is where they touch. This is where they are adjacent. So it's adjacent to this segment made from this overall hypotenuse. So that means that this 3 is going to be on the bottom. Since I know I'm dealing with a geometric mean, this guy and this guy I know is going to be the same. Automatically, these two numbers are going to be the same. I actually have a thing in my brain. I go boom, 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 boom. So I go this guy over this guy is the same thing as this guy over what it touches over this guy, which is the connecting hypotenuse. Since this is the hypotenuse, this guy touches it, it's going to be on this side. It also works when it's on this side as well. So boom, 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 boom. Then I solve for y. So y squared equals 3 times 9 is 27. So y equals the square root of 27. I could pull out a 3 and a 9. So y equals 3 times the square root of 3. Okay. So the length of the hypotenuse of the biggest triangle over the length of the hypotenuse of the smallest triangle. This length of the smallest triangle is the same thing as the short leg of the biggest triangle over the short leg of the smallest triangle. And this is the side that they touch. I know. Alright, which gives us to 2. I'm not going to write this. You guys can copy it from here. Geometric mean of the altitude. Alright, so ABC. In a right triangle, A, B, C. In a right triangle, it says the altitude of the right angle to the hypotenuse divides the hypotenuse into 2 segments. The length of the altitude is the geometric mean of the length of the 2 segments. Alright, here is the altitude. The altitude is CD. CD divides these guys into 2 segments. We have segment AD, which is the bigger segment that has been cut, and we have segment, and we have this altitude, CD. The altitude is going to be the mean. All right, the altitude is going to be the mean. So it says the length of the altitude is the geometric mean of those segments. So when we do this, it's going to be this segment, dB, over the altitude, CD. Since this is a geometric mean, it says that altitude is the geometric mean. So then I know that this CD is going to occur twice. And it's going to occur over the other segment. So dB and AD are the segments that got cut from the altitude, and then the altitude itself is the geometric mean. So geometric mean of the altitude, I go, boom, 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 boom. So dB to CD, and then CD to AD. It kind of goes, in my mind, it kind of goes in a sort of like a loop. And it goes both ways. I could go AD over CD is equal to CD over dB. It goes both ways. So boom, 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 or boom, 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 boom. All right, this is the geometric mean of the altitude. Then you have the geometric mean of the leggies. So same thing, but now we got these legs. So don't worry too much about the altitude. That's not the geometric means of the legs. So here we go. So we got this guy, and we got this guy. All right. Then we also have the altitude, or the hypotenuse. So when they talk about the geometric means of the legs, they're talking about the geometric mean of the legs of the biggest triangle. So AC is the bigger leg of the biggest triangle, CB is the smallest leg of the smallest triangle, and AB is the hypotenuse. If we look at CB, CB touches the hypotenuse over the biggest triangle at DB, right here. If we look at AC, AC touches the hypotenuse, the overall hypotenuse AB at AD, right here. So when we do this problem, and we set this up, it's going to be the hypotenuse AB over, let's do the smallest one, so over CB. Now notice that CB is also the hypotenuse of the smallest leg, right? It's across a 90-degree. This is going to be the geometric mean. So CB is the hypotenuse of the smallest leg, while it's also the shortest leg of the biggest triangle. So the reason why it's called the mean of the legs is because it's the legs of the biggest triangle. So since this is the mean, I do CB again up top, and I put that over what CB touches. CB touches the hypotenuse of the overall triangle at DB. So this is going to be DB. All right, so this is the geometric means of the legs of the shortest leg. Then we have the geometric mean of the legs at the biggest leg. Again, starting off with the hypotenuse of the overall big triangle. So AB over, and then we're going to do AC, because that's the next leg. Right? So we did the CB, which is one leg, and now here's the other leg of the other triangle. So AC, why are you not blue? And since it's the geometric mean, I know it's going to be the diagonal, and that's also going to be AC. AC touches the hypotenuse of the overall triangle at AD. So it's going to be over AD. Hypotenuse of the overall triangle over the hypotenuse of the medium, which is also the same thing as the long leg of the medium over, or the long leg of the overall triangle over the long leg of the medium, all right, or the side that it touches. So when I think about it with the boom booms, boom, 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 boom. It says in example 3, which theorem would you use to solve for y? So if we go back to example 3, we used hypotenuse of the leg because we're looking for the leg of the biggest triangle. So hypotenuse over the leg, or hypotenuse of the small, which is the same thing as the leg of the big over the leg of the small. So geometric mean of the leg. We were using 7, 7. All right. We have this person who has this 90-degree angle, is looking straight across it to this wall. They want to know the length of W. So if you notice, we have the altitude of the overall triangle. So that means that we're going to use the geometric mean of the altitude. So the geometric mean of the altitude, I'm going to draw like this. This is the overall hypotenuse. So if I was going to draw the altitude, this is 5, this is W, and this is 8.5. So since it's the geometric mean of the altitude of the overall triangle, the altitude occurs twice. So I can say 5 over the altitude. And that altitude is the same thing as the just the long leg of the medium, same thing as the short leg of the or long leg of the small. So short leg of the small over short leg of the medium is the same thing as the long leg of the short over the long leg of the medium. Okay. So this is going to be 5W equals 8.5 squared, which is equal to 72.25. Divide that by 5, and you get 14.45, which is about, we're going to go to the nearest tenth since I think that's what the book says, 14.5. Using the geometric mean of the altitude. They want to know how big this wall is. So since I know that's 14.5, I can add 14.5 plus 5, and that gives me the length of the wall, which is 19.5 feet, approximately. Short, really short person. All right. All right, if Mary was 5.5 feet tall, how would this have worked? Okay. How long would, how far from the wall? All right, so if she was 5.5 feet tall, how long would the altitude be? So if we were to change this problem, this is now going to be x. This is now going to be 5.5. We already know how long the wall is 19.5. So 19.5 minus that guy is 14. Alright. And then we still use the geometric mean of the altitude. Now we're looking for the altitude. So it'll be 5.5 over x is equal to x over 14, because it's the geometric mean. So x squared equals 5 times 14, which gives me 77. So I'm going to square root both sides, so x equals the square root of 77. So that gives me approximately 8.7 feet away. So the person is a little bit taller. Since there's a little bit taller, this just shifted, and this distance away is going to be longer by a little bit. So it looks like the taller you are, the longer you have to go back for this to be a 90-degree angle. So yeah, that makes sense, because if she's taller, I would have to shift higher. And if I have to shift higher, that makes the distance here longer. So that makes total sense. Alright, so that is that section. I hope you have a great rest of your day.